So good afternoon, everyone. So this is the session before lunch, so I will try to make it on time. So I'm Richard. So today I'm going to talk about how we can use privacy-enhancing technology on AWS to protect data privacy when doing data collaboration. And this is me, Richard. I'm an AWS security hero, but I'm not an AWS employee. I'm a security engineer from a big VPN company, and I'm also an AWS Nitro Enclave contributor, so which Nitro Enclave is a service that I will also talk about in the later stage. Okay, first of all, I want to talk about two stories. The first one is this one, Facebook disaster map. Who haven't used Facebook here? So I assume everyone uses it. So have anyone seen this pop up when during some disaster nearby, when Facebook asks you, okay, are you safe from this disaster or something else? I believe someone has seen it. So, so besides clicking I am safe and Facebook help you to post an okay, I am safe status on Facebook, what did it does? Like, it's actually a part of an initiative called Facebook Disaster Map. So this program which Facebook used the user data such as their geolocation and also the response of the safety check question we have seen in the previous slide to help make the disaster response more efficient and effective. So there's one example is there's flooding in India in 2018. So the flooding displaced millions of people in that area, Kerala. There's a humanitarian agency in India called SEEDS, S-E-E-D-S. They use the real-time information of the trend that those affected when they will go home to like see the return home. So they use the data shared by Facebook to estimate the time on when they should distribute the humanitarian aid to the affected. The second story is in 2012. A man called Jelani Henry, he was arrested on 2 counts of attempted murder in New York City. But despite of the lack of evidence, he was denied bail, also being in jail for 19 months. And the only reason why the judge put him into jail is that the prosecutor portrayed him as a known member of a gangster. But the evidence is only because he has liked some of the photo of the gang member in Facebook, and also they have some group photo here with the gangster posted on Facebook. But this case is eventually dropped because there's no evidence that he's part of the murder. And this is only one of the many cases that the government use our social media data to spy on us, to profile us on what we look like. So in this era where we have so many digital footprint, sometimes the data would be, our privacy data would be some data for good, which help on things like disaster response. We have looked into the Indian flood case. However, it can also be abused, especially when data privacy is concerned. So how do we make this data collaboration and data privacy live together? And to enable broader data collaboration without compromising the underlying data privacy, actually there's a discussion this several years about privacy-enhancing technology, or we call it PET. So the PET is a set of technologies that help to maximize the use of data without compromising the data privacy, without making it riskier. Here are some examples that is more broadly discussed. I'm not going to talk about it one by one, but those techniques is basically try to minimize the data privacy leak when we do data collaboration. Some may be more advanced anonymization technique. Some are to prevent data being exposed when doing data processing. Some technologies here are still in development and require advanced knowledge to use it, but some are relatively mature that we can actually use it on AWS. So I'm going to talk about 3 of the techniques and how we can use it on AWS. The first one is AWS Nitro Enclaves. I also talk about, I'm also a contributor on the ecosystem of Nitro Enclaves. It is a trusted execution environment running in EC2 instance. So first of all, we need to talk about what is trusted execution environment. So it is basically a secure area of our processor. It's isolated from the rest of the system, and it cannot be even accessed by the system admin and the OS. So it's like a very secure environment for us to process the data without anyone going into it. Besides AWS Nitro Enclave, there are actually many more examples. For example, Intel, they have SGX, which is a isolated environment inside our Intel processor, which can do stuff that other application or even the OS system cannot touch it. Interestingly, NVIDIA is a very hot topic right now because it's a powerhouse of AI. They also announced their confidential computing on their GPU last year. So talk about AWS Nitro Enclave. So Peter has talked about the Nitro system. So thanks to the Nitro system, we can use Nitro Enclave as you can treat it as a container running inside the EC2 instance. But it's actually not within the same EC2 instance. It's actually running like running in another EC2 instance, but logically it's inside our same EC2 instance. So what it does is, first of all, it's just like a Docker container, but no admin access, no persistent storage, and also no external networking. So we can build our image inside this Nitro Enclave running it, and nobody can touch it. So imagine we can put the data into the Nitro Enclave and do the processing, and we can ensure that nobody can touch it. So in the data collaboration scenario, how we can make use of Nitro Enclave. So right now, on the left-hand side, we have data owner. We want to do some data processing or maybe doing some research on some customer data. But we don't want the customer data, the customer privacy be compromised. We can ask the data processor to write their processing program, and then we audit it. It is safe to use. Then we run the processor in the Nitro Enclave, and we can make sure that the data is within the Nitro Enclave, and the data owner will not see each other data. Data processor cannot see the data from the data owner as well. And we can ensure the data in use is being protected. But there are some nuance is that because the Nitro Enclave is run by the data processor, how can we ensure that the program is run not like a backdoor that just leak the data into the S3 bucket or whatever? There is a concept called attestation document. It's actually a document signed by AWS describing the Nitro Enclave on what it is running. And then by passing that attestation document to the data owner can verify that this Nitro Enclave is really running the data processor that we meant to use before sending the data to the Nitro Enclave. So right now we are anchor the root of trust to AWS rather than the data processor. The second one is federated learning. Federated learning is a machine learning method. So when we do machine learning, we want to use data to train it. But imagine we have 4 parties. They all own their own data. But we want to train a global model that can fit all the data from these 4 parties. Instead of pushing the raw data into the central server to train a model, we can do federated learning. The data owner will host their training process to train the local model themselves. And then they push the local model to the aggregator and to update the global model. So right now, the aggregator can train the central model without looking into the raw data of the data owner. This is called federated learning. And it's especially popular in medical use because we all know medical data is very sensitive. We don't want to share to other people. But medical research needs many data. We cannot use just a part of patients' data to train a model that can accurately predict symptoms. So we need to collaborate with many medical institutions to train an accurate model. Then federated learning is very useful for them because those data owners can use their local training method and then to do the training. And Amazon SageMaker is AWS ML managed service. So there are many different features like building model, training the ML model, and even deploy the ML model. One of the features is for SageMaker is distributed learning. So originally, this feature is for us to we have a large scale of data, a terabyte of data. We want to train a model. We want to make it faster. We can split the data into different chunks and train the model in parallel to make it faster. But by using the same concept, we can even make it a federated learning setting. So instead of splitting the data into chunks, we can even split the training instance into different accounts and use VPC peering to connect all these training instances. And with the help of some federated learning libraries like FedML, OpenFL, et cetera, we can set up the distributed learning across different accounts. So imagine we have account A, account B, which is two different training data owners. They can put their training data into training instance and then push the local model into the third account, which is a central account, to update the central model. This can help us train a global model without these two accounts exposing the data into outside of their own data account. I'm not an ML expert, so I'm not going to talk about it into detail, but there will be some resource at the end, so you can reference it later. And before talking about the third one, I want to talk two more stories. The first one is about in 1990s. So there's an organization called Group Insurance Commission. It was responsible for purchasing health insurance for the state employees in Massachusetts. And the company think the medical data, because the insurance company need to collect the medical data for the state employees to help them purchase the health insurance. They think this kind of data is not very sensitive because it just contains some medical visit date, diagnosis, just birth, date of birth, gender, zip code. Is not very sensitive because no one can identify who is that person. So they share the data to some data researcher if they want to do some research. And there's a PhD student named Latanya Sweeney. He thinks this kind of data is actually sensitive. So what she did is she obtained the medical record from the organization. He also find the voter registry of the Massachusetts. And then what she target is the governor. She want to extract the governor's medical record from all this medical record provided by the group. So how she did it is, first of all, she find the voter registry of the governor, and then she cross-match these two data, and then she find that only 6 people have the same date of birth with the governor, yeah, and only 3 of them are male, and only 1 person have the same zip code with the governor. So obviously, this one is the governor. Yeah. So just by cross-matching these two data, she can find out the medical record of the governor. So the second story is about the Netflix prize, which is in 2006. So the competition is to use the subscriber data to train a method for the movie suggestion algorithm. And so to help the participant of the competition, Netflix provide the subscriber data to the public. But this time it's not stupid. Netflix is not stupid. They didn't include any personal data into the data set, only the movie rating record and the subscriber ID. But then this time still, there are 2 PhD students from the University of Texas still managed to identify some of the subscriber identity. How they do it is they use the IMDb. IMDb is another online movie database that allow people to use their profile to comment on the movie. So they cross-check these 2 data sets and find out some profile from IMDb that can match to the Netflix data set. But you may think just movie rating is not very sensitive. But let me give you an example of it. Let's say John, he has some comment on these 2 blockbuster movie. He did it because everybody loved this movie. He is also happy to share his feeling on these 2 movies. But at the same time, he also rate these 2 movies, which is probably more sensitive because it may expose that he is maybe a Christian or his political stance against the federal government because he loved this documentary criticizing the US government response after the 9/11. He didn't do the same on IMDb because he knows it will reveal his, some of his belief or political stance on IMDb. But then, if we cross-match these 2 kind of data, we now know John is loves the movie of Jesus of Nazareth. Maybe he's a Christian. It's not expected in the first place by Netflix or even John that his political stance may be exposed by cross-matching these 2 data. So what these 2 stories I want to talk about is no personal is exactly the same as the others. So if we have enough data, all data is potentially a PII. Why? Because just like the governor's example, just the date of birth, zip code, and the gender can reveal someone's identities. So differential privacy is a solution of that. So let's talk about what is differential privacy. So differential privacy have 2 main idea. First of all is privacy budget. It's a very fancy name, but it's actually we can treat it as how best someone can hide from my question. So let's take this example. If I ask how many people live in US, okay, if we have John in this data set, probably 100 people live in US. But if we take out John, it's only 99. And then if I ask another question, how many people live in Monterey? John is the only one live in Monterey in this data set. If I take him out, the result will drop from 1 to 0. It's a significant drop compared to this 100 to 99. So what privacy budget talk about is how John can hide from my question. If I ask how many people live in US, I probably doesn't know John is inside the data set, because many people live in US. So if it gives me a result of 100, maybe I cannot guess, okay, maybe John is within this data set or not. But if I ask the same question, another question, how many people live in Montreal? If I know Montreal is a very small town, and John probably lives in Montreal, and if you give me the answer 1, probably I can guess maybe John is within this data set. So this is about privacy budget. And in reality, we cannot control where John lives. Like, if he really lives in a small town, how can I help John to hide from my question, how many people live in Montreal? We'll add noise when using differential privacy. So if I ask the same question, how many people live in Montreal? The answer will not always be 1. Maybe we will output 0 or 10 or 2 to confuse the people. So by using this noise, we can protect John's privacy from the query of the data set. So in summary, differential privacy is if we have a lower privacy budget, the more privacy preserved, because just like if I ask how many people live in US, John is just one of the 100 people live in US, so John can maybe hide in the crowd. So that means we have a lower privacy budget consumed. And if we add higher noise into it, we can help lower the privacy budget, and we have the same outcome, more privacy preserved. And if we add higher noise, there's a side effect, is it will lower the accuracy, because sometimes you give me the answer is 1, sometimes give me the answer 10. So exactly how many people live in Montreal, I don't know. So we can see that differential privacy is just a concept. So actually we can use AWS Cleanroom. AWS Cleanroom is a service that helps people to expose their AWS glue table without directly exposing it. And we can add some analysis rules on the AWS Cleanroom to restrict the query capabilities of the data consumer. So I'm not going to talk about it in detail, but basically we can, last year, AWS Cleanroom have added the differential privacy as one of the analysis rule supported. We can try it out on AWS Cleanroom and see how differential privacy works in action. So as promised, I'm not going to run out of time before the lunch. This is my LinkedIn. You feel free to connect with me. And this QR code is exactly this slide deck. I have added some reference link into it. So if you are interested in any slide, you can check it out. And I have a blog post series talking about differential privacy and also Nitro Enclave. If you are interested on what is going on with my presentation, you can also check it out. Yeah, that's it. Thank you.